And now, the moment we've all been waiting for, why did I teach us how to factor? So, quadratic equations, right? They're degree 2 equations. They got 3 terms, and they're of the form ax squared plus bx plus c, okay? This is a quadratic equation in standard form. We have a zero factor property, and that property states that if I have 2 factors, like a and b, then either one has to be 0, or the other has to be 0, or both have to be 0. So let's take a look. Let's say a is 7 and b is 0. Well, then ab is going to be 7 times 0, which is 0. Okay, let's let a equal 0 and b equal -5, right? Then AB is still going to be -5 times 0, which is 0. And if they're both equal to 0, then I also get that AB equals 0. So in order to solve for x, right, when my equation equals 0, so hint, we're finding the x-intercepts of our parabola because the graph of quadratic functions looks like a parabola, and it can either have no x-intercepts, 2 x-intercepts, or if it's just perfectly like on the x-axis, it's going to have 1 x-intercept because we're letting our function be equal to 0. So if I take x plus 6 equals 0 and 2x minus 3 equals 0, I get x equals -6 and 2x equals 3, so x equals 3 halves. I just found my 2 x-intercepts for this parabola. So what am I going to do to solve a quadratic equation by factoring? So the first thing I want to do is get it written in standard form. I need to factor it, and then I use the zero factor property to find the solutions. So this first example is almost in quadratic form, but I got to move this 2 over. So now I have 2x squared plus 3x minus 2 equals 0. Now I need to find the factors of AC that add up to b. So what are some factors of -4 that add up to 3? How about -1 and 4? I can pull that middle term apart. We're pulling our middle term apart into 2 pieces. So I have 2x squared minus x plus 4x minus 2 equals 0, and then I can factor by grouping. I need so much more room. Okay, the greatest common factor of 2x squared and x is an x, so I get x times 2x minus 1. The greatest common factor of 4x and 2 is a 2, so I get 2 times 2x minus 1 equals 0. I collect what they had in common, and what's remaining. Now I can use the zero factor property to solve. I have that x plus 2 equals 0, and 2x minus 1 equals 0. So I get that x equals -2, add 1 to both sides, and I get that 2x equals 1, so x equals 1/2. These are my 2 y-intercepts for this quadratic function. I'm going to go ahead and write the other 2 down on a piece of paper for myself, so that I can open up a new window. So we're going to keep solving these. So my 2 equations were 4x squared equals 4x minus 1 and 4x squared minus 20x equals 0. So I need to get this in quadratic form. I do that by subtracting 4x and adding 1 to both sides, because that makes the right hand side of my equation equal to 0. I then find the factors of AC that add up to b. 4 could factor into a -2 times -2. So those are going to be my 2 factors. So I've got 4x squared minus 2x plus 1 equals 0. Now I factor by grouping. So I have 2x times 2x minus 1, and then -1 times 2x minus 1 equals 0. I get 2x minus 1 squared because I have 2x minus 1 and 2x minus 1. This means I'm only going to have 1 x-intercept, which means my graph touches the x-axis. just a little. So if I have 2x minus 1 equals a 0, because it occurs twice, we're still going to get x equals a half for both of these. But we say 1/2, oh, you can't see that. We say 1/2, but it has a multiplicity of 2 because it occurs twice. Now in orange, let's take a look at 4x squared minus 20x equals 0. I want to go ahead and pull out the greatest common factor because I've only got 2 terms. That's going to be 4x times x minus 5. So I get 4x equals 0. Divide both sides by 4. X equals 0. I get x minus 5 equals 0. Add 5 to both sides. X equals 5. So here are my 2 solutions to this quadratic equation, also known as its X-intercepts. Let's do a couple more examples. If I have 3x squared minus 108, let's go ahead and pull out a factor of 3. That gives me 3 times x squared minus 36 equals 0. Well, I know this is going to factor into a sum and difference. So I can go ahead and take each of these terms and set it equal to 0. So I get x equals negative 6 and x equals 6 as my solutions. Next, I have 2x squared plus 5x minus 7. So what are some factors of AC that add up to b, which is 5? Well, how about negative 14 factors into a negative 2 and a positive 7? I can now factor by grouping. 2x squared minus 2x gives me 2x times x minus 1. 7x times and negative 7 have a greatest common factor of 7. So I get 2x plus 7 times x minus 1 equals 0. I then set each of those factors equal to 0. I get that x equals 1. I subtract 7 from both sides. 2x equals negative 7. I get x equals negative 7 halves. So these are my 2 solutions. Next, I have negative x cubed plus x squared. I want to subtract this to get to the other side. Well, I'm going to add it. Plus 6x equals 0. I can pull out the greatest common factor, which is a negative x, because we don't want a negative leading coefficient. So I have negative x times x squared minus x minus 6 equals 0. So now I need to factor this part here. I want to find the factors of AC that add up to b. Well, that's going to be a negative 3 into 2, because negative 3 times 2 is negative 6, and negative 3 plus 2 is 1. So I have negative x, my leading coefficient is 1, so I can go ahead and write this as x minus 3, x plus 2 equals 0. So this was a degree 3 equation. So it could have at most 3 x-intercepts. So I have to set each of these equal to 0. So I have negative x equals 0, which means x equals 0. If x minus 3 equals 0, so x equals 3. And I have x plus 2 equals 0, so x equals negative 2. Those are my 3 possible solutions. Now what if I have x squared equals 9, and I want to set this equal to 0 and solve, right? So I have x squared minus 9 equals 0. That's a difference of perfect squares, so it's going to be x minus 3 and x plus 3 equals 0. So I'd get x plus 3 equals 0, x minus 3 equals 0. So I have x equals negative 3, and x equals 3. But what if I could have just solved this by taking the square root of both sides? That would give me x equals the square root of 9. Where if I take the square root of 9, because it's a square, it could be negative 3 squared is 9, or it could be 3 squared is 9. So my answer would be plus or minus 3. Okay, here's 2 possible ways to solve this problem. This is called the square root property. Okay, and this is how I solve these equations. So I can go ahead and take the square root of both sides. Oops. I get x plus 3 equals plus or minus 4. So I'm going to have to take x plus 3 equals 4 and x plus 3 equals negative 4, right? Because it's plus or minus 4. Subtract 3, so much subtraction. I get x equals 1 and x equals negative 7. Let's try that again. I take the square root of both sides. X minus 2 equals plus or minus the square root of 5. So I have x minus 2 equals plus the square root of 5, and x minus 2 equals minus the square root of 5. Leave it in radical form, please, 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 please. Thank you. So I'm going to add 2 to both sides. I get x equals 2 plus the square root of 5, and x equals 2 minus the square root of 5. And that's how I use the square root property. Thus, we have completed Chapter 5, and I'm very much looking forward to Chapter 8, where we're going to start to graph and look at the graphs of quadratic equations. By the way, we're skipping 6 and 7. We're going to go to 8, and I promise we'll come back.